Welcome to the Product Design Show. I'm Allison Tupperwine. Last week, we looked at the role that empathy and collaboration played in design thinking.
In today's episode, we'll explore the last two components of design thinking, integrative thinking and experimentalism. I'm Vince Penman.
Integrative thinking and experimentalism are the most game-changing elements of design thinking.
In a nutshell, integrative thinking is the process of taking opposing ideas and creating a product that harmonizes them.
Oftentimes, these opposing ideas exist at the intersection of desirability, what the customer wants, feasibility, what is technologically possible, and viability, what is economically sound.
Instead of allowing these elements to stifle a designer's ability to create a great product, integrative thinking asks designers to reference each of these elements to create a superior product.
This is where experimentalism comes into play in design thinking. To harmonize these three competing ideas, designers have to think creatively and look for bigger solutions to the problem at hand.
Let's look at how one engineering firm used integrative thinking and experimentalism to engineer an incredible architectural feat.
CST Covers designers had a daunting task ahead of them when they were asked to engineer the cantilevered roof at the Francis A. Gregory Library in Washington, D.C.
Designers had to find a way to support the library's massive cantilevered canopy while still retaining the elements of design set forth by the architect.
Because of the canopy's complex and undulating geometry, no out-of-the-box solution would work for this project. CST's team needed to begin experimenting with designs and geometries that had never been tried before.
The primary concern in the design was how to retain the architect's vision while compensating for the immense forces that would try and bring the roof down.
Designing a cantilevered structure is no small feat, but engineering one where the canopy moves in both the horizontal and vertical directions across its entire span requires a lot of thought and, of course, experimentation.
The team's experimentalism helped them understand that a rigid canopy would never fit the architect's vision because it would sag and contort as gravity acted upon the structure.
To counter gravity's effects and retain the architect's design, CST's team were led down paths that had the canopy twisting and contorting to compensate for all of the forces that were in play.
Through their experimentation, they found that an assembly-based hub and tube configuration that included pre-cambered tubes and an adaptable hub would satisfy their budgetary, technological, and aesthetic constraints.
The pre-cambered tubes, designed with a bend that would compensate for the roof sag, ensured that the architect's vision for the canopy would be accurately produced. Connecting each undulating section provided another design challenge.
A hub structure that could be tailored to each joint in the assembly was needed. Designers at CST Covers constructed a hub model that could adapt to the unique bolt position of each tube as they undulated through space.
From this model, unique hubs could be manufactured for specific connection points along the canopy span, and the roof could be completed section by section to ensure the structure's accurate construction.
If engineers at CST Covers weren't willing to bring an experimental approach to this design challenge, they may never have found a way to build the cantilevered roof at all, let alone at a price that met the project budget.
By not compromising on the project's three main constraints, desirability, feasibility, and viability, the team leveraged integrative thinking and experimentalism to create a remarkable work of architecture.
In the last two episodes, we've looked at the four key elements of design thinking. Empathy and collaboration showed us how designing with a focus on the customer can help direct your concept design process towards more meaningful product development.
And integrative thinking and experimentalism gave us better insight into how we can turn real-world constraints into avenues for making more innovative products.
Used together, each of these elements can help your team create more impactful designs by providing new tools to use in each phases of the design process, especially product concept design.
Thanks to PTC for sponsoring this episode. You can see their tools that support product concept design at ptc.com/go/creoparametric.
And thanks for watching this episode of the Product Design Show. Please give it a like on Facebook, subscribe on YouTube, or give us a rating on iTunes.